Hello guys, this is Arcane Pool. So Arcane Pool is a encrypted and private AMM extended over the encrypted ERC20 protocol, effectively making it a dark pool AMM. But it's verifiable on chain with all the compliance controls. Okay, so why are we building this? So DeFi has a privacy crisis. Okay, from front running and MEV to total surveillance, there is a issue with privacy and attacks when the swaps are public. Okay, so we are solving it by making the swap private, completely private. So how are everything private, right? So all the balances are encrypted by LGML ciphertext. Okay, so the identity balances and swap amounts stay encrypted. Okay, and also it's compliant by design because of the auditor control. Okay, so how do we swap? It's so simple. Just enter the swap amount, the zero knowledge process generated, there's atomic on-chain execution and reserves update publicly. Like, let's check this out here. Okay, so you can create new users here if you want. Like let's say I'm creating a new user with some funds on both the pool. This is basically for testing, that's why we can add the funds as we want. So the account is created. Now we have a balance of 500 and here is the pool balance. So let's say we want to swap this much. Okay, if we swap it, we are generating zero knowledge proof on the client side, on the user side, and submitting it on the blockchain. Okay, so there we have, as you can see, the pool stats has been updated and we have made a swap, but nothing is being revealed. Okay, so you can also check the docs if you want to see how it works. Okay, so here's what's hidden and what's public. Okay, the trader identity, swap amounts, user balances, transfer linkability and balance history, everything is like encrypted or hidden. What's public is the pool reserves, obviously, which should be public, and the swap direction and the trade count. Okay, and the auditor has the control to decrypt transaction amounts, and generally it's sender and receiver because it's extended over encrypted ERC20, right? So the sender and receiver can be decrypted on encrypted ERC20 using auditor. So how are we achieving this? Okay, so the encrypted ERC20 standard supports LGML encryption, homomorphic encryption over baby jub curve. So the balances are stored this way, and there to ensure the transaction, to verify the correctness without revealing the private inputs, which is LGML encrypted. We are using ROT16 zero knowledge circuits. Okay, so we have 5 circuits by default: registration, mint, withdraw, burn and transfer in encrypted ERC20, and we have privacy commitment tuple PCTs, which are basically Poseidon commitments. Okay, which lets auditor decrypt individual transaction for compliance without revealing data publicly. Okay, so how is this being executed? A swap is being done by 2 zero knowledge encrypted transfers. Okay, so there is a pool. Okay, so the trader inputs a token to the pool. This is the one transaction, which is input token transaction, and the pool again sends another transaction to the trader, which is the output token transaction. So these are the two legs of the transaction, the two zero knowledge verified encrypted transfers, which ensures the swap. Okay, so why Avalanche? The main reason for choosing Avalanche is the encrypted ERC20 token protocol, which is unavailable anywhere, and obviously the auditor compliance, without which the product would not be allowed to run. So currently there are no private swap solutions, like the private swap solutions which are compliant using auditor PCTs. So this ensures everything. Okay, the user identity, swap amounts, balances, MEV exposure, compliance, execution, everything is checked out. So for now we have 6 smart contracts, 6 zero knowledge circuits, and all the tests that we have in the repository, and one command run which launches everything up and running, so which can be tested from the GitHub repository itself. For the future work, currently we have implemented this much: a private identity swap, okay, operator approval transfer from pattern, constant product AMM, and full suit with real zero knowledge proofs. And currently we are implementing single swap circuits. Currently there are two circuits which are being generated. Like, one is on the user side for the transaction and one is on the pool side for the pool's transaction. Okay, so single swap circuit is currently the priority, and we are pushing everything to testnet after having a single swap circuit. Okay, because right now we are having two zero knowledge circuits for proving a transaction, and one needs to run on the backend, which is the pool side, which cannot run on the device side. Okay, so to fix this, we are currently implementing single swap circuit, then we'll push everything to testnet. So that's it for now. Thank you.